we'll try to subnet this question 192.168.1.0/24. We want to create 7 subnets. Like I told you, the first thing I will always do if I'm actually going to solve this in an exam is to write out the powers of 2's. That's the first thing you need to do. It's going to make your life easy. And you start from 2 to the power of 0 to 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, 2 to the power of 7. 2 to the power of 0 is 1, 2 to the power of 2 is 2, 2 to the power of 3 is 4, 16. What's the next one? 2 to the power of 4 is
16.
Huh? 2 to the power of 3 is 8, 2 to the power of 4 is
16,
16,
32, 64, 128.
and 128. So you know why it's up to 7, because 0 to 7 is 8
bits.
Alright, so this is our question here. We need to create 7 subnets. The first thing you want to do after you've written down your power of 2's is to try to understand what the subnet mask is. In this situation, we have 192.168, 1.0 and /24. /24 means our subnet is 255.255.255.0
class B.
Right? Now this is a class C IP address. Now, if I write out this subnet mask in binary, it'll look something like this: 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. So all ones represent the network, all zeros represent the host, right? The question is, we need to create 7 subnets. How do we do that? Now, every time you subnet, you are borrowing bits from the host and giving those bits to the network. We are creating 7 subnets. What do? We'll come back to the powers of 2's. We look for 7. Is there 7 on the powers of 2's? No. What's the next number closest to 7? 8. 8 is the next number closest to 7. So we're going to take 8. 2 to the power of what gives us 8? 3. So it means we're going to be borrowing 3 bits from the host and giving to the network. So this is our network portion. You go to the host portion. We're going to borrow 3 bits. So if we borrow 2 bits, it's going to be 1, 2, 3. We're going to be borrowing these 3 bits. So it means these zeros automatically become 1. And the rest of the zeros is for the host. Okay? Now, let's rewrite this. If we're going to rewrite this, our new address will be 192.168.1.0/24/25/27. That is our new address in CIDR notation. So 192, I'm just going to put it up here, 192.168.1.0/27. Okay. You know the IP, you know your address in CIDR notation. But we need to write this address out because there are 7 subnets. So we need to write out all the addresses for each of those subnets. How do we do that? You know, we go back to an old trick which is called the magic number. Let me write out what we had before. So the subnet mask we had before is 1, 2, 3, 4, 5, 6, 7, 8, right? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So these are subnet masks. Now, how do we determine what the address of each subnet will be? I said we use the old trick of magic number. How do you calculate the magic number? Come to the octets where you borrowed bits to the network. How many bits are left for the host? 5, right? 1, 2, 3, 4, 5. Right? Come back to your powers of 2. 2 to the power of 5 is what?
32.
That tells you that each subnet has 32 addresses. Each subnet has 32 addresses. Like I said, listen to what I'm saying. Addresses is not the same as usable addresses. Addresses includes the broadcast and the network. Usable address does not include the broadcast and the network. And usable address are the address you can assign to hosts. You cannot assign any host the broadcast address. You can't assign any host the network address. So the magic number of 32 tells us that each subnet has 32 addresses. Now, how do we write out the subnets? Let's start from the first one. The very first subnet will be 192.168.1. So the same address they gave to you will be your first subnet. So our subnet 1 will be what? 192.168.1.0 all the way to, remember we said each subnet is 30, it has 32 address.
31.
Right? Now this is one easy way to do this. There are two ways to do it. You can either subtract. No, don't subtract one. You might get confused. Take this number you have here, add it to the last number you have here. That gives you 32. So 0 plus 32 is what? 32. Then subtract 1 from it. That's 31. So it means the end address will be 31. 192.168.1.31. That will be the end address because 31 to 0 is 32 addresses. Right? So from 0 to 31 is 32 addresses. So like I said, to calculate the end, take the number you have here, you take a magic number, add it to this and subtract 1. That gives you the end address. Then subnet 2.
32.
This, add 1 to it again, it gives us 32. So 192.168.1.32 all the way to, add this to this again, what does that give? That gives us 64 minus 1.
63.
63. 192.168.1.63. Then subnet 3 is what? 192.168.1.64. 64. Then again, add this to this. What does that give you? That gives us 6, 7, 8, 9. That is 90. That's 96.
96.
So that's 95. 192.168.1.95. So subnet 4 is what?
95.
192.168.1.96. Add 2 to it. What does that give us? 6, 9, 10, 11, 12. 12.
128.
12, so that's 128, right? Minus 1.
And 127.
192. Now I'm going to just start, 192.127. Just to make it fast. Subnet 5 is what? 192.168.1.128 to what? 32. What does that give us? That's 10.
130.
What did you say?
69.
No, so you have 32 here. So this is 10. That's 5. That's 6. 6. Right?
Yeah.
159.
Yeah.
So dot 159. So subnet 6 is what?
160.
192.168.1. 160, right? All the way to what?
192. 192.
191. Then the last one is what? 192.168.192
192.
all the way to what? Huh?
203.
Huh?
123.
120. 223.
223?
Yeah.
So that's the answer is to create 7 subnets, but the truth is that in reality there are 8 subnets. It was 2 to the power of 8, right? 2 to the power of which is 8.
8.
There are 8 subnets here. So if you want to write out the last subnet, it's up to you. But the question says you create 7 subnets. If you want to write out the 8th one, it's up to you. The 8th one is going to end at 25254. That's where it's going to end. Now, these are your subnets. The first question I may ask you is this. What is the first usable IP address in subnet 4? This is subnet 4. What is the first usable IP address there?
97.
97. Any other person? What's the first usable IP address in subnet 4? It's gonna be .97 because remember we said the first address and the last address cannot be assigned to anything.
So,
The first address, this right here is a network address for subnet 4, and this .127 is the broadcast address for subnet 4. So if I ask you what is the last IP address in subnet 4, what is it going to be?
it's 126.
126. Any other person? 126. Any other person? The last IP address for subnet 4 is 127. I said, listen to the question. What is the last usable IP? What's the last usable IP address in subnet 4? It's 126. What is the last IP address in subnet 4? It's 127.
Okay.
So I said, listen to the question. If I say usable, I am telling you to only tell me the value after you subtracted -2. If I don't use the word usable, give me as it is. That's what I'm saying to you.
But the first usable address would be 97 only.
The first usable IP address will be 97.
97, yes.
The first IP address is
96.
You understand how the questions are asked?
Yes.
It's a little bit tricky, but if you listen to the question, if you read the question and understand the question, you know what we're talking about.
Yes.
So it's easy, right? It's not difficult. It's easy. Now, if I ask you what is the subnet mask of the subnet, what will be the subnet mask?
27.
Let's write out the subnet mask. You know, we said it's 111.111.123 and 0. So how do we convert this to decimal subnet mask? Not CIDR. Yes.
Usable IP address 96.
Yes. No, usable IP address is 97. First IP address is 96. First usable IP address is 97. But the first IP address is 96. When we ask you for usable IP, what I'm asking you to do is to subtract 2 from it and tell me what the first number. But it's easy. If I ask you the first usable, just come to your first address and subtract 1 from it. No, add 1 to it. If I ask you for last usable IP address, come to the last IP address and subtract 1 from it.
It's a usable address.
Usable, yes. Usable IP, the last usable IP,
Is
come to
126.
the last address, subtract 1 from it.
126.
Yes. The first usable IP, come to the first IP, add 1 to it. So go forward and backwards. Depends on what you're looking for. Now, how do you convert this to decimal? You have this in binary, you want to convert it to decimal. You know, it's a subnet mask. For us, what's a subnet mask? I'm going to give you, now, most of the questions I'm going to give you, the subnet mask is going to be in decimal, not in binary. So how do you convert this to, to decimal? We're going to come back here. I'm going to wipe this off. You already understand this part, right? You understand this portion. Let me wipe this off. Now let's do this. Let's do this this way. So I have that in decimal, in binary. I need to convert it to decimal. How do I convert it to decimal? Come back to your powers of 2s. You see all of this. Transpose it and put it on this powers of 2 tables. You start from the first one. The first one is going to be at the top here. So you have 1 here, 1, everything here is 0, 0, 0, 0, and 0. Now, how do you now convert this to decimal? Wherever you have 1, what is the decimal value there? The first one you have 128. Plus, you have 1 here. What is the decimal value?
64.
64.
Plus 32.
plus the next one you have 1 here. What's the decimal value?
32.
32.
Every other one is 0, so you don't bother. But then anywhere you have 1, you look for the decimal value, put it there, and add it up. When we add all these three together, what does it give us? So 128, 64, and 32. This is 12, and this is 14, right? This is 6, 8, 9, 10, 11, 12.
224.
224. So it means our subnet mask will be 255.255.255.224. That's our subnet mask. So when you're configuring this IP address on your computer, that's the subnet mask that you're going to use. Any question?
Sir, this subnet mask we are going to use on a broadcaster.
No, that's the subnet mask. You know when you're configuring IP address, you put your IP address and the subnet mask. I told you the subnet mask tells us how many bits represent the network. So this is the subnet mask you're going to use for any of the subnets that you want to configure in this example.
Okay.
Now, this is easier. This is simple. I will show you the difficult one now. What time do okay, we have let's move to variable length subnet mask, VLSM. VLSM is actually more difficult. No, not difficult per se. But okay, good. One thing I didn't tell you earlier is this: when if you notice, when we're calculating, or when we're trying to find out, or when we're trying to borrow bits, we were borrowing bits from where? We're coming from the host and giving to the network. But when we are doing VLSM, we are going the opposite direction. Why? In your subnetting, we know the number of network we want to create, right? Which is a subnet. But we don't know how many bits we want to borrow from the host. But in VLSM, we know the host, we don't know the number of network we want to create. Because the number of network is variable. I gave you an example in the morning. I said, for example, if he wants 50, he wants 100, he wants 200. I will take one single subnet and break it down to match your needs. In subnetting, all the subnets we create are equal. In VLSM, the subnets we are creating are not equal. You have 50, he has 100, he has 10, and she has 200. How do we create that? I'll show you really quick, if we still have the time. Now, I'm going to write this stuff on this side. The powers of 2's. Let's do powers of 2's here. 2 to the power of 7, 2 to the power of 6, 2 to the power of 5, 2 to the power of 4. So 1, 2, 4, 8, 16, 64, 1, 2. Alright, listen up. Now, I'm going to paint a quick scenario because I don't want to waste too much time. Usually I take my time to paint it, but let's paint a quick scenario. Now, let's look at this scenario.